Okay, and a lot of you all had like the right idea when it came to, you know, writing them, but I just wanted to kind of just show it for everyone here. All right. So, as we'll just jump right in with an example here. So, write a polynomial that has the given roots. Okay. Write a polynomial that has the given roots. All right. And so we'll start with some, you know, simpler ones, and then get some more complex ones. So, for example, let's just say that we have roots of -8 and 2. Okay. So, if we have roots of -8 and 2 for this mystery polynomial, right? What could we then say might be our factors for this polynomial? Okay. X plus 8 and x minus 2. Sure, because sure enough, right, if we set either of those two factors equal to 0 and then solve, you would get the -8 and the positive 2 there. Right? Both of those numbers would make us, you know, equal to 0. Are those the only two factors that we could come up with to give us roots of -8 or 2? Are those the only two? Like, are these unique, right? Are those the only two we could have, or are there more? Any ideas? Devin? Right, yeah. So, like, for example, x minus 2, probably the most straightforward route to take, right, to get a root of 2. But we could also have, for example, 2x minus 4, right? Because 2x minus 4, when you set equal to 0 and solve, you'll add the 4 to both sides, divide both sides by 2, and you'll still get that positive 2, okay? And the same thing is true for the x plus 8, right? We could make it 2x plus 16, you know, and so on and so forth. And so, in fact, there's an infinite number of solutions that would work for this particular question, right? I'm expecting most of us, right, we'll just go to these, you know, but there's really an infinite number of polynomials that could work here, which makes grading these sometimes a pain if people try to be cute with, like, their different answers. So, I would appreciate it if you try and just go for the most straightforward ones, but do understand there are infinite ones, and anyway, so yeah. All right, so there it is, and of course we could, you know, multiply it out if we wanted to, make it like x squared. Let's see, plus 8x minus 2x, so plus 6x minus 16. Okay, but really, you know, this one's good, but this is technically answering the question right here. It's just x plus 8 times x minus 2. Okay, but we should be comfortable with giving either answer there because, you know, yeah. I guess that's more of a polynomial then anyway. That's not really a polynomial, so I guess that one is. Okay, let's try another one here. Alright, how about the roots are 4 and -1/3. So the roots of 4 and -1/3. What might those factors be? Caleb? Okay, so x minus 4, and you said 3x minus 1? Okay, so if we set x minus 4 equal to 0, you can add 4 to both sides, you get x equals 4. Yep. And if we set 3x minus 1 equal to 0, you would add 1 to both sides, and we have to divide both sides by 3, and so it would be x equals positive 1/3. So we don't want 3x minus 1, what should it be instead? Yeah, just make it plus 1, make it plus 1, 3x plus 1. There we go. That'll make us then have a root of negative. Okay. Exactly right. And again, that's not the only one, right? So for example, we could do, you know, kind of what Kayla did here for the x minus, the 4, the root of 4, she made x minus 4. We could just as easily say for this root of x, of the root of -1/3, we could just as easily say x plus 1/3. That would also give us a root of -1/3. But of course, when you're multiplying with fractions and stuff like that, maybe you don't want to do that, right? So this is probably the most straightforward one, I would say. Debatable, I guess, but anyway. So 3x squared minus 12x plus 1x, so minus 11x, and then minus 4 And voila. Okay, so there's our polynomial. Alright, so that's pretty straightforward stuff, right? Pretty straightforward. Alright. So these are all rational roots. And we got integers here, and here's we got rational numbers with the fraction stuff. Let's try one more here together, and I'll have you guys try one. So what about with like roots? Because these, you know, if all the problems were like this, you know, you guys would have maybe all gotten that bonus right, or like many more of you would have gotten that bonus right. But this was these roots right here, where we have something like 4 plus or minus the square root of 3. That can really mess people up, or that's what like kind of threw people off. They're like, how do we tackle this, right? Those rational roots, we can tackle that pretty easily, but these really threw people for a loop in that bonus. Okay. So, a couple ways to think about this kind of problem. We can, first of all, kind of solve it the same way that we did before, right? So, if these two things are roots, sorry, not these, yeah, these two things, 4 plus root 3, 4 minus root 3. So that means like x equals 4 plus root 3 is a root, but also x equal to 4 minus root 3. Right? The plus or minus really means two different solutions there. 4 plus root 3, 4 minus root 3. And then to get the factors here, we can just get the thing equal to 0. So we'll say that, okay, that's x minus 4 minus root 3 equals 0. And then x minus 4 plus root 3. Right? We just put everything back over so it's equal to 0. And so then these two things are our factors. Those two things are the factors. And so, you know, we can multiply those things back together. To get our polynomial. Alright, now, to multiply these two things together, we have a couple options. Alright, option 1, we can just take every single term here, all three terms here, and make sure they multiply to all three terms here. So I could do like the x times the x times the negative 4, the x times the root 3. And then do negative 4 times x, negative 4 times negative 4, negative 4 times root 3. And then do negative root 3 times x, negative root 3 times negative 4, negative root 3 times root 3. And then combine like terms and solve. Simplify. And that's one way to do it, right? It's just to distribute everything here to everything here. That's one way to go. Okay. Alternatively, if you look in here, right, if we group things, you'll see that we have the quantity x minus 4 minus root 3 times the quantity x minus 4 plus root 3. Okay. Or, to put it more bluntly, we have, you know, some quantity, we can call that x minus 4a. We have the same x minus 4 right here. And then we have this root 3, we'll call that b. And then we have another root 3 here, the same quantity right there. Except 1 is a minus b, 1 is a plus b. What do we call this situation where we're taking a minus b and multiplying by a plus b? What is that? Difference of squares. Yeah, this is the difference of squares. Okay, this is exactly the difference of squares. So we know when you do a minus b times a plus b, you're going to end up with a squared plus b, sorry, a squared plus b squared. It's a difference, Mr. Whitmire. A squared minus b squared. Okay. So in other words here, that x minus 4 is going to be x minus 4 squared. And that minus b squared will be minus the square root of 3 squared equals 0. And so then when we multiply this out, we get x squared minus 8x plus 16, and then minus 9 equals 0. And you can simplify that. X squared plus minus 8x plus 7. So there's that way, all right, using like it ends up being a difference of squares, and this will be true in general. There's one other alternative. So again, there's kind of three kind of paths we take here, right? We could just distribute everything here to here, right? Multiplying like it's a difference of squares, Or there's one other way where if we take our root here and say, okay, this is x equals 4 plus or minus the square root of 3, right? A root is kind of like a solution to that equation if it's equal to 0. All right. So rather than splitting it up like I did here, just, oh yeah, question? Did I make a mistake?
It shouldn't be minus 9 because root 3 squared would be 3.
Aha. Math. Arithmetic. Thank you. Plus 13. Okay. Yes. All right. So again, arithmetic, important, right? But anyway, so then x equals to 4 plus or minus root 3. All right, one other alternative we have here, right? The big problem is this square root, right? Like if this square root wasn't there, we'd be kind of good to go. So what we can do here is if we subtract the 4 over, we can eliminate that square root by squaring both sides at this point. Okay. Again, when you square in an equation, you can't like pick and choose where you square. It's the entire left-hand side gets squared, the entire right-hand side gets squared. So x minus 4 quantity squared is x squared minus 8x plus 16. And then plus or minus the square root of 3 squared. Well, if you square positive root 3, it's just 3. If you square negative root 3, it's also just 3. So it's going to be 3 either way. And then you can, you know, subtract the 3 over. And there's your polynomial a different way, too. Okay. So a couple options there about how to multiply this all out. A couple options for those things. Questions on any of that? All right, then here's for one for you to try. All right, so give this one a go here. Again, same directions. Write a polynomial that has given roots. In this case, the roots will be 1 plus or minus 2 root 5. Okay. So you all try that one there. multiply fractions, all you do is multiply across the top and multiply. Yeah, there you go. Yeah. That is. Yeah, so far so good. Yeah, not bad. Just square it. Yeah. Nice. Well done. Well done. So like 20 is on the other side of the equation from this. So it's gonna be a positive 20, so you're gonna subtract it over, so you want to take away from it. Yeah.
I got everything else except my count. Because I found the 20 side.
That is, yep.
So I put it in there.
So it'll be just it's this, which you got to be this, right? And then just minus 20. Just like bring it on down along with everything. Okay, so there is what we should have gotten. X squared minus 2x, excuse me, minus 19 equals 0. Questions on any of that? I did it like the kind of technique I showed you there. I can multiply it out in a different way if you'd like to see it in a different way too. Here, like the difference of squares, I didn't use difference of squares. But yeah, all I did was just subtract the 1 over, so it's x minus 1, and squared both sides here. You can square the quantity 2 root 5. Okay? When you square that quantity 2 root 5, you can distribute the square because the product is 2 times root 5. So you can just do 2 squared and root 5 squared, 4 times 5, and that's 20. Okay. So there it is. All right, questions on any of that? All right. Very good. So that's all I wanted to show, just, because that was that bonus question that I gave you like ages ago, and I wanted you to see how to actually do it now. All right. So next topic, and we're going to like really change gears here. We're going to look at graphing quadratic equations. Excuse me. Okay. I guess we'll just go to this. We'll just do it this way. Alright, so again, graphing quadratic equations by hand. Okay. Now, granted, you guys are all pretty well versed in this, right? Like in years past, before Common Core and stuff like that, this was maybe a little bit more new-ish or less comfortable. But I think most of you guys are way more comfortable with this, than in the past. But we'll still, kind of talk about some things here. We're going to focus on. For our purposes, and you can feel free to use, whatever other strategies that you have, for doing these things. But we're going to focus on 3 main aspects of the graph. Okay. And again, there's so one thing, for example, we won't look at, well, never mind, I'll go about the first 3 things and I'll talk about the other stuff too. So one thing, right, we want to be able to find y-intercepts. Okay. And actually, how many y-intercepts will a graph of a quadratic ever have? 1, right? Just 1, at most 1. Actually, it'll always have 1. It should cross the y-axis at some point. Okay. And so the y-intercept, right, is always of the form what? Or what do we always know about a y-intercept? What about its coordinates? Yes, 0 and then something, right? The x-coordinate will always be 0, right? If it's a y-intercept, by definition, that means it's on the y-axis. And any point on the y-axis is going to have an x-coordinate of 0. It's going to be 0, comma, blank there, right? And then, similarly, the x-intercept, or we could also say the roots, okay, or root, right? I guess I should put that x-intercept there. Well, anyway. So, what would an x-intercept always look like? What do we know is true? What will always be true about an x-intercept for its coordinates? Something 0, right? Yeah. So blank, right? Comma 0. We can always have always have a y-coordinate of 0 because it's on the x-axis by definition. And as far as quadratics, what can we expect about x-intercepts for a quadratic? Is there anything we can expect? Any limitations on our x-intercepts? We can say for sure. Any constraints? At most 2, right? And that's based on the shape of that graph, right? We know quadratic is a degree of 2. Talking back about those polynomials, right? When we found the zeros using like synthetic division and the rational roots test, right? We know that the highest degree, the degree of the polynomial, is going to tell you the most number of roots you can expect, right? And so, yeah, since the quadratic is degree 2, we can expect at most 2 x-intercepts, 2 zeros. All right. And one other point that's important, right, is that vertex. Okay, and this one, obviously, there's no like specific, numbers we know it will always be, but h and k, right, are kind of like the standard variables used for the x-coordinate and y-coordinate, respectively, of that vertex. Okay. There's other words for the word for that meaning of vertex. So we know, again, knowing the shape of a parabola, the vertex is either, going to be the highest point or the lowest point of the graph. Okay, and so you can talk about that. That vertex will also be like the maximum or minimum, depending on the orientation of the graph. Okay, I think in like physics too, the vertex is called the apogee. Can anyone confirm that? Apogee, like if you're talking about like the flight path of like a, an object through the air or something like that, I think the vertex, the peak of the flight path is called the apogee, I think, but I'm not sure about that. So anyway, I heard an engineer use it not long ago, and so I was like, I think that's right. So anyway, okay. So those are the 3 main points we want to focus on, right? Like there's also like the axis of symmetry, and absolutely we know that quadratics are symmetric, right, about that axis of symmetry, right, that vertical line that goes through the vertex there. So you can feel free to use that to your advantage, when you're trying to graph these things, up to you. And of course, whenever it comes to graphing anything by hand, we always can fall back on that table method where you guess an x value, plug the x value into the quadratic, get the matching y value, and then plot the points that way too, and just kind of connect the dots, right? That's always, an option as well. But these are the 3 main things we want to focus on, finding in each kind of problem. So let's just jump right in here to a problem now, and let's just say we want to graph, f of x equals x squared plus 8x plus 7. All right, so let's find that y-intercept here first. And the y-intercept has 0, comma blank, right, as its coordinates. And so since we have 0 for the x-coordinate, we can plug in 0 there. So we'll just be like, y equals 0 squared plus 8 times 0 plus 7. So we know that y is going to be then 7, right? Y-intercept is pretty easy to calculate. 0, 7. the x-intercept. Okay, that's always going to have, you know, blank, comma, 0. So now we'll just put 0 in for the y there. So now we have this equation we ought to solve, right? We can, since it's already equal to 0, though, we can use that zero product property. Does this thing factor?
Yeah.
Yes. To what?
7.
7 and 1. X plus 7, yeah, and x plus 1. And so we get then x equals -7, and x equals -1. And so, you know, -7, 0, and -1, 0. Those are our two x-intercepts, so I guess I could like do it this way. There we go. Okay, so we found the x-intercept just now, right? Found the y-intercept a little bit before that, and then we have the vertex. Okay. And there's quite a few options for finding that vertex. Okay, and you can use whichever method you want to find the vertex, right? You won't always be able to find x-intercepts, right? We said that the graph will have at most 2. That means you could have 2, 1, or 0. So you won't always be able to find x-intercepts, right? Sometimes they will be imaginary, so we wouldn't have any, right? Y-intercept, you should always be able to find that. And a vertex, a quadratic equation should always have a vertex too. So there's a lot of different ways to do that, though. So option 1. Okay, the x-coordinate for a vertex is equal to -b over 2a. Okay, the x-coordinate for the vertex is equal to -b over 2a. So in our case, right, our b is 8, so that means it's equal to -8 over 2, and then our a value here is 1, so 2 times 1. And -8 divided by 2 is -4. So that is one way you can always get the x-coordinate for the vertex. And then once we have the x-coordinate, how can we find the matching y-coordinate? What can we do? Plug back into the equation there. So yeah, f of -4 equals, you know, -4 squared plus 8 times -4 plus 7. And so we get 16 minus 32 plus 7. So -9. So we have a vertex at -4, -9. So that's one option. -b over 2a, right? That right there. Alternative to that, though, we can use some other things to our advantage. So, for example, a quadratic equation is symmetric. Our quadratic equation is symmetric. The graph is, right, about that axis of symmetry. If we have the two zeros, we can find the midpoint. We can find the mid-x coordinate there between the two zeros. So, one way we can do another way to do the vertex is to get, you know, find the x-coordinate by finding the midpoint of the x-intercepts. Okay. So to find the midpoint of the x-intercepts there, you're going to take that -7 and add -1, and then divide by 2. Okay, that'll help us find the midpoint. So -7 plus -1, -8. Divide by 2, -4. Okay. And there we can kind of see already what's going to happen, right? -4, there's the x-coordinate for our vertex. We already see that, right? And so in step 2, find the matching y value for x equals -4. And we know then we're going to get, -4, -9 there as well. Okay. So again, option 2, right? And then option 3, again, just to throw you all the different options here. Option 3, you may remember that there's this form called vertex form, right, of a parabola, of a quadratic equation, whatever. Right now, I think this is called standard form, x squared plus 8x plus 7. But vertex form is nice because it shows, it gives you the vertex just by reading the equation. Just like slope-intercept form for a line, if you look at the equation, you can tell immediately what the slope and the y-intercept will be. If you get this quadratic equation into vertex form, you can just look at the equation, right, and know what that vertex is going to be. And the way we do that is by completing the square. From the standard form, at least, right? So, but it's like, how do you complete the square when there's no other side, right? Like there's no equals to here. So we can't really add the same thing to both sides because it's not really equal to anything. Like we just have this thing that we're trying to graph here. So how do we add the same thing to both sides here? How do we do that, right? Well, what we're going to do instead here is very similar. We're going to leave a blank, and we're going to have the plus 7 out here. So we're going to kind of hold that plus 7 off to the outside, right? We're going to leave it out here. It's still part of our problem, right? It's still there, but we're not going to use it just yet. Okay, we're going to complete the square in the normal kind of way that we would. And so what number will we add in here to help complete the square for x squared plus 8x? What are we going to add in? Mr. Meyer, that was back in the very first week of class. You can't expect me to remember this. That's okay. What would it be? What? 16! That's right, Sarah. That's right. So we're going to add 16, right? Remember, it's half the middle term, so half of 8, 4, squared, so plus 16, okay? But of course, normally what we do then is okay, we put plus 16 in there, and then we'll add 16 to the other side. But we can't do that. There's no other side. So how do we balance it out here? Well, instead of adding the same thing to both sides, we're going to add 0, right? So if I'm adding 16 to this, quantity here, I'm going to also subtract 16. And so that allows us to now have it balanced still, right? Or it's still equal because we didn't add anything other than 0. We added 0 to this thing. We added it in a tricky way. So we can then factor this thing to be x plus 4, quantity squared, and then minus 9. So we can think about this in a couple ways, right? The way this is written now, is in a kind of transformation format from our original x squared, right? It shows some shifts are happening. X plus 4 quantity squared, right? That means that plus 4 means we're shifting to the left 4, and that minus 9 means we're shifting down 9. So from the original, from the parent function, the vertex is at 0, 0, we're going to go left 4, down 9, and so our vertex will be negative 4, negative 9. Okay? Or if you want to use that vertex form, remember vertex form is x minus h quantity squared plus k. Okay, so there's your vertex there. The plus 4 then is minus a negative 4, and then minus 9, so the k is a negative 9. And so there you can see it more easily. Okay, the hk for the vertex there. Okay. Questions on any of that? All right, so we'll stop there, and I'll give you guys your assignment. Okay, so that's it. I'm not going to give you one to try because I feel like you guys have seen this enough that maybe we can just jump right into the homework assignment so you guys can get started on that. Okay, so let me get that for you here. The homework assignment is out of the book. And it's going to be page 132, numbers 7 through 12, 37 to 39, 76, and 79. Okay, and then 76 and 79 are calculator required. Okay, so make sure you definitely use a calculator on 76 and 79. Okay. Oh, thank you.
I found mine.
Oh, good. Was it at home somewhere?
No, it was in my bed.
Oh, gotcha. Yes, okay. Well, that's good to hear, Alyssa.